This is CS1101, lecture 11.2. We're going to be going over objects again, and specifically we're going to be talking about accessor and mutator methods, as well as the ideas of public and private methods and instance variables. In the last lecture, we looked at a solution for reading student information from a file and storing it and then printing out a subset of that information into another file. In the initial solution, we used three parallel arrays, one for the student name, one for the student age, and one for the student GPA. Then we said maybe we can do this better if we use a single array of type student, where the student is an object. The student is an object that can store age, name, and GPA. When we set about coding this, immediately it was obvious that the code was going to be easier to write and easier to read. So this is going to have, a very major effect on how maintainable the code is. Easy to write, easy to read code. Typically it's easy to maintain code. And as a reminder, arrays of objects require two-phase initialization. You have to create the array and initialize the array. But when you do this, every element of the array contains a null pointer. So then you have to instantiate an object and assign that object's reference to each of the elements in the array. So here's where we left our code for reading students' information in from a file into an array of type student. So as a refresher, we have a scanner that's reading from a file object. We get the next integer, which is the first integer in the file, which is the number of total student records in the file. We create an array that is long enough to have one element per student in the file. And this array is called stuinfo, and it's of type student array. Then we begin to process each of these records by processing from 0 to I less than student count. And we process it by creating a student variable called S. So this is a reference variable, S. And we are building a new object in memory of type student and storing the reference in this variable S. We get the information for this student from the file and then store the reference currently stored in S into our array. If we have more files to process, we come back to the top, create a new student object, rinse and repeat. Do this until I is no longer less than student count. So now that we've built this student object and we don't have to read into three separate arrays and then read out of those three separate arrays to write the student name and GPA to this other out file, how would we go about using our student array called stuinfo to output a single record with the current setup? Well, we would have some sort of system.out.print stuinfo, and then I is the element in that array that we want to access. And we use the dot operator, which dereferences the address stored in this array element, and we access the instance variable name in that object. Then we concatenate that with a string, which is a comma, which contains a comma, and then concatenate the student GPA just as we did with the student name. This will work. And we can generalize this to write every student record by using a for loop that goes from 0 to I less than stuinfo.length. So notice in the last slide what we said about the solution for printing out student info was this will work. But can we do better than this will work? Is there something we're missing? Is there something we should do? Yeah, we should look at this and decompose it just like we should every other problem and programming task. So what should the appropriate decomposition be for writing student info? Should we just code a for loop into our main? No, probably not. It makes more sense to write a method so that we don't have to constantly rewrite this statement over and over again in our program. So we write a method to be able to take in a student and some particular print stream called out. So we could pass in system.out, and that would be a print stream, or we could pass in a print stream object that pointed at an output file. There's different ways we could go about this, and then use out.print. So in this way we can write a method so that we don't have to constantly write system.out.print open parentheses s.net. You see what I'm saying? So by writing this into a method, we're reducing redundancy. Good. We've decomposed this problem. We found a bite-sized piece, and we have appropriately made a method to handle that particular bite-sized piece, writing a particular student to an output stream. Okay? Then in our main, we would call our write method. That's better than using a for loop in the main and having to brute force write all these to an output stream. But one thing we're missing here is the major benefit of object-oriented programming, and that's code reuse. So while we have written a method to be able to print a particular student's information to an output stream, and we can reuse that in our program all over the place, someone else who imports our student class won't have that write method. You see what I'm saying? So if we make this student class and we distribute it to the whole college, everybody in the college wants to be able to store information about their students more succinctly and with more efficiency. So we distribute this student class to everyone in the college. Well, we don't distribute the write function. We didn't think of that. So then each person individually has to figure out how to code their own write method. So every person that uses the student class winds up having to duplicate this same work of figuring out how to write a student's information to an output stream. One other thing is that when we have created a method where we have to pass in the object, this is not typical for how we typically deal with methods that apply to some object. Ordinarily, you would expect to see something like stuinfo element I dot and then calling the method. Here we're calling the method, passing in the student object, and then also passing in the output stream. So this is a little bit different. It's a little bit of a deviation from what we usually see when we're dealing with objects. Remember what we've said previously about classes. They should combine the relevant state information as well as typical behaviors. So when we were dealing with points, the relevant state information was the X and Y data, and the behaviors that were typical, not to enumerate them, but one was finding the distance between 2 points. So we decided that a point should have member instance variables for the X and Y location, as well as a member method for calculating the distance between the point stored in that particular object, in that particular instance of the object, and some other point which was passed in. Well, now that we're dealing with students, the student info here is going to be, or the student state information is the age, name, and GPA. What sort of behaviors do you think would be typical of a student object? It seems to me that printing the student information to some output stream would be something that was typical that most people who use this class would want to do. So rather than coding a separate write method that is not a part of this class, we should include the write method as a member of this class, so that anyone who uses the student class in the future will have access to this member write method. And as a reminder, when we refer to things that are members of a class, we're talking about the instance variables and methods which are written into a class so that we can access them using the dot operator. These methods that we want to be members of a class are referred to as instance methods. We refer to our fields in a class as instance variables because there is a new copy of that instance variable in each object that we instantiate. So these variables exist as a part of each instance of the object. The very same thing is true with these methods. A copy of this method exists as a member of each instance of the object. So each object has its own methods associated with it. And this is how we encode behavior into our classes. The syntax for declaring an instance method is similar to the syntax we've used previously for methods, with one important exception. We don't include the keyword static. So we say public, and then whatever the return type is, and then the name of the method, any parameters that we're going to pass to the method, and then the statements. So as an example, if we wanted to have a method that just prints out a name, the name of the student, and says, I love CS at Vandy, we could say public void, show some love, and then the statements that we want to execute when this method is called, which would be system.out.println, and then it's going to access the name instance variable, which is a part of the student class, and concatenate that with says I love CS at Vandy. So when we revise our student class to include write as an instance method, it'll look like this. We'll have our instance variables, string name, age, and double GPA. And then we'll have our instance method, which is public void write, and we'll pass it the print stream we want the information written to. But here's a question. How does our instance method know which student to write? You understand what I'm asking? This method is part of the student class, and we've instantiated an object of type student, so we have a student instance, and we're calling student.write and passing it some print stream as a parameter. But how does it actually know what the name is and the GPA to be written? The answer is the specific instance that is calling the method is an implicit parameter to the method itself. So when we call s1.write and pass the print stream that we want to write to, our write instance method knows which instance of the student object called it, and it is able to therefore deduce which instance variables to use when executing the method. So our instance method write is going to automatically know that we're wanting it to use the instance variables which are stored in the object that is the implicit parameter. That's the object to the left of the dot when we use the dot notation to call write. So when we say s1.write, the write method knows any access to instance variables inside this method should use the instance variables stored in s1. When we say s2.write, s2 is now the implicit parameter, and so write knows to use the instance variables stored in s2. These instance methods that we're going to make use of come in two varieties. First is the accessor. This is a method that we use to get some value from the object. So an example of this would be if we added the instance method getGPA to our student object. So this method would return the value stored in the instance variable GPA. Or getName. GetName would return the string stored in name. So these are all about accessing some information stored in our object, accessing some instance variables. So the Boolean method isOnARoll would also be an accessor method. It would return some Boolean value that was derived from the GPA. So accessor methods don't have to simply return an instance method value. They can return a value that is derived from an instance variable. So in this case, isOnARoll is taking in the GPA, which is stored in the object, and deciding whether or not that is an honor roll GPA, and then returning a Boolean value of true or false. That's still an accessor method. It's a method that reads the instance variables and then returns information about the object. Since these methods are all about accessing information stored in the object, it's typical that they would not have a void return type, right? Because we're wanting to get some information about the object. So if we're getting information, then most likely something will have to be returned to the caller. The second variety of instance method would be a mutator. A mutator is a method that is going to change something about the object. So an example of this would be setGPA or setName. So in this case, setGPA would have a parameter, which would be the GPA that you want to set the instance variable GPA to. So we pass setGPA, let's say 3.1, and setGPA will then change the instance variable value to 3.1. SetName is very much the same. We would pass it the new name for this student object, and then setName would change the string which is stored in the name instance variable. So mutators are called mutators because they're mutating the object. Typically, mutators will have a return type of void because they're not returning information, they are changing the state of the object. So now that we've brought up accessor and mutator instance methods, it's time to talk just a minute about encapsulation. Typically, you would not allow someone to directly access the GPA, which is stored in the instance variable GPA. Rather, if they wanted to access that value, they would get the value using getGPA, so an accessor instance method. And if they wanted to change the value, then they would use the mutator setGPA. We'll talk more about encapsulation in coming slides, but for now, think of it as a way to increase readability and to control what sort of values are allowed to be set. As an example, in this setGPA method, we've defined a very simple setGPA method, but think we could have written it so that we check to see if new GPA is actually a valid GPA, right? So GPA should be in the range of 0 to 4.0 in a typical GPA system. So we could validate that the new GPA is in that range before we assign our instance variable the value new GPA. So it's a way of increasing readability and controlling what sort of values are placed in the instance variables. In the following slide, we're going to modify our student class to include mutator methods. We're going to add a setName, setAge, and setGPA instance method. So we're modifying our student class to include the mutator methods. First of all, remember, mutator methods are going to change the object, but we're not attempting to access information stored in the object. We're mutating it, not accessing anything. So we're not going to have to return anything. So we'll make these methods public. They're not going to be static because they're instance methods. And they're not going to be void. Well, they are going to be void because we are not returning anything. So public, void, and then let's start with set name. So set, and it's already guessing at what we want to set because it knows the instance variables that we have in the class. So let's just go ahead and choose set name. And we are going to pass it a string parameter called new name. And we're not going to do any input validation yet. So rather than processing to see if this is a valid string, or a valid name, I should say, we are going to directly set it into our instance variable. So we say name equals new name. Notice it immediately knows that we're wanting to set the instance variable name because the instance variables are accessible in any method in this class. So we have written our setName mutator method. Now let's write our setAge mutator method. Same thing, public void setAge. And then we're going to pass an integer for an age. So int new age. Same thing, age equals new age. Finally, we're going to include a mutator for the GPA. So public, and then we're not returning anything, so void set GPA. And then int new GPA. GPA equals new GPA. So now we have created our mutator methods, which are instance methods of our student class. Let's recompile our student class so that when we want to use them in our client class, we don't have to then recompile our student class. So we can choose to recompile student.java, and we can see at the bottom of the screen it's recompiling, parsing, and finished. Now let's go in our client and let's adjust how we're setting the values into name, age, and GPA. So rather than accessing these instance variables directly, we're going to use our mutator method, set name. Set age. Set GPA. Oh, chose the wrong one. GPA. So we'll do the same thing for S2. So we're removing the way we were modifying the instance variables and instead using the mutator methods that we've now included. But it says we have errors, and the error is with our setGPA method. It says that it was expecting a parameter of type integer, but we provided a parameter of type double. So the reason that we're getting this error is because we declared our setGPA with an integer type new GPA. So this is a useful way to be able to tell that you have errors in your program. See, the name of the Java class client is underlined in red, means there's an error. We have an exclamation mark in red right here. If we hover over it, it says two errors found. And then we also have red lines under the specific errors. So let's adjust our student class instance method declaration or instance method heading and declare this parameter as type double. We'll save it and we'll recompile it. There we go. Now we have no more errors. Good. So now we're appropriately using our mutator methods to set the values in our instance variables. Let's run this program to make sure that it still works. Yep. So now we are storing Jake, 18, and 3.4 in the name, age, and GPA of S1 and storing Hannah, 18, and 3.7 in S2. Then we are writing their information to the console. So we can see that we have correctly written their name and GPA. So we mentioned this when we were doing the example, but we want to make it very clear here. Notice that there's no declaration for GPA, age, or name. That's because we're not declaring a new local variable to this method. Rather, we're accessing the instance variable that is accessible by all the methods in this class, all of the instance methods. Let's also modify our student class to have an instance method for writing the name and GPA to the console, or to whatever print stream we happen to pass to it. So let's have public void because we're not returning anything, and we called it write. And we'll pass it a print stream object called out. Notice it's angry. Can't resolve print stream. I didn't uppercase? Yes. Okay, now why is it angry? Still can't resolve it. It's because we need to import the relevant java.io package before we can make use of print stream. So even inside a class file like this, we still have to import all the relevant libraries if we're intending to use things like print stream. So then in our write method, we're going to say out.println, and then we'll access the name instance variable, concatenate that with a string that has a comma in it, concatenate that with our GPA instance variable. So now let's modify our, well, actually let's first of all, no, oh, okay. Yep. Again, make use of this. I noticed there was a red underline underneath student.java. I forgot to put a semicolon after my import statement. So now we're good. So now let's recompile. Done. Let's go back over to our client, and instead of having to write out this print statement, let's now call our S1 and S2 dot write methods. S1 dot write, and the print string we want to use is system dot out, and S2 dot write, and the print string we intend to use again is system dot out. So in our student.java, we have this instance method called write. And we're passing a print stream object, and we're using that print stream object to print the instance variable name for this current instance of student and the GPA. So in our client, rather than having to manually print this out, we can use instance methods, as we've discussed, to write the instance variables to whatever print stream object we choose to pass. In this case, we're passing system.out. We could just as easily pass a file print stream object. So let's run this code. Now notice in our write method, we didn't print this student's name is, we just did Jake, comma 3.4. So it should give us Jake, 3.4, Hannah, 3.7. There we go. So at this point, the current state of our student class is the instance variables we have defined, our mutator age method, which sets the age, the mutator GPA method. It's not shown here, but we also have the set name mutator method. And now we have also added our write method. So this would be an accessor. We said typically accessor methods are going to return some value, but in this case, the way that that value is returned is to some print string. So we have our mutator methods, and we have created one accessor method to be able to output the name and GPA to some print string. So thus far, we've been able to access our instance variables outside of our class anytime we wanted using the dot operator, right? So we said we should use the mutator methods that we declared, but we've not strictly prohibited anyone from being able to access the name, age, and GPA by just simply saying student.name or student.gpa. The reason that they're able to access it in this way is because when you create an instance variable, it defaults to public access. But in truth, instance variables of a class should not be public. We should set them to private. So we need to add the keyword private to our instance variables. Why might we want to set our instance variables to private? We all understand how an ATM works from an abstracted point of view, right? We don't necessarily understand the circuitry, but we know we can go to an ATM and we can insert our debit card, access our bank accounts, get money, deposit money. We know the basics of what an ATM allows us to do. But an ATM doesn't allow us to directly access the value in our bank account, right? So we can't go to the ATM and on the screen type in what we want our new bank account balance to be. We can't access the value stored in the bank account balance instance variable. Imagine if we could. Imagine if you could just go to an ATM and directly access the account balance instance variable. Then you could just type in any value you want. There's no level of control over what a user might do. Someone may go to the ATM and enter the value 1 million for their account balance, even though they haven't got $1 million. But they do now because whoever made that ATM allowed everyone to have direct access to the instance variables. So instead of giving everyone direct access to this account balance instance variable, this ATM has the instance variable set to private. And then we are able to adjust that account balance by using the deposit money instance method. So in Java, we use the private modifier to make some instance variable inaccessible from outside of our class definition. So any instance variable that has the keyword private on it is not going to be readable or writable from outside the class without using a mutator or accessor method. However, inside the class, we're still going to be able to adjust the instance variable and to be able to read the value of the instance variable. So if an instance variable is set to private inside the class, we can access and modify the value freely. But outside the class, we can only access the value using the accessor method, and we can only modify the value using the mutator method. So anyone who imports our class and makes use of it will only be able to access and change instance variables through the public instance methods in the class. This is why we want to code get and set methods for each of our instance variables. So to make sure we've ground this into the ground and it's perfectly clear, nothing outside the class is going to be able to access any instance variable or field if it is declared to be private. So if we had a class that had the instance variable ID and name, and we declared both to be private, if a client program attempts to access these variables directly, then an exception is going to be thrown by the compiler saying that that instance variable has private access in that particular class. So in the next slide, we're going to modify our instance variables to prevent anyone from accessing them outside the class. So now let's modify our instance variables so that we cannot access them outside of this class. We do that by adding the private keyword to the front of the declaration. So private string name. Now these instance variables will not be accessible outside of our class method. Let's recompile. Parsing, done. Okay, so now we can show that we're able to still run our file pretty easily. It's our client file. So let's run our client program and show that that still works. There we go. But now let's show that we can't access those instance variables directly. So s1.name. First of all, notice IntelliJ is smart enough to not even allow us to try to write to or read from the instance variables that are set to private. So we type s1 dot, there's no option to access name. But we can make it, let's just say s1.name, and we're going to try to print it. So system.out.println. And we have an error. We're outlined in red, and we also have this .name is in red. So here it says name has private access in student. So without even trying to compile this, we know that there's an error. We could try to compile it or run it. Let's try to run client.main. Oh, name has private access in student. So we are not allowed to directly access the name instance variable. So now we're controlling how it can be accessed. So now we have successfully encapsulated the instance variables in our student class.